the Roots of the Science podcast with your girl, Anne with an E.
Hello, everyone, and welcome to another episode of the Root of the Science podcast with your girl, Anne with an E. Today, we are on episode 34, which is still mind-blowing to me every single time that we do this. And a usual reminder that if you want to start your own podcast, you can use Buzzsprout, and you can find a link in the show notes which gives you a $20 Amazon gift card to start your show, and also it also helps you support this show. So go ahead and click in the link in the show notes. Now, let's get into today's episode. My guest is Brooks Musangu. He is a PhD student in nuclear physics. He's originally from Zambia and is now studying in America. After college, he was introduced to the United States Achievers Program that picked the best performing students from Zambia to study in America. In this episode, we learned that he's currently a student in physics at Vanderbilt University in Nashville, Tennessee, in America. He is studying low energy experimental nuclear physics, specifically studying the nuclear structure of neutron-rich nuclei. He will explain all of this research in detail and also give us a breakdown on the significance of this research. Brooks also talks us through a typical day in the lab for him, which is before COVID happened, and some of the many opportunities that being in the field of STEM, specifically a nuclear physicist, has afforded him. Lastly, we discuss the hot topic of young Africans who study abroad and who tend to set firm roots in their new country, with some not returning to their country of origin. We get his take on this controversial topic. So take a listen to hear about all of this and so much more. Let's go. Hi, Brooks. Welcome to the show.
Hey, how are you, Anne?
I'm great, thank you. How are you doing?
I'm doing good. Thanks for asking.
Oh, no, I'm really excited to have you on the show and just for people to get to know more about you and everything that you're doing.
All right. Well, I'm excited to be here. Thanks for having me.
Okay, great. So let's just get into it. Can you please tell us a bit about yourself, where you're from, where you're based, and what are you currently doing?
All right. Well, I'm originally from Zambia, and like I stated earlier, my name is Brooks Musangu. Originally from Zambia, currently based in the USA, Nashville, Tennessee, and I'm pursuing my PhD in physics, specifically in nuclear physics.
You're my first nuclear physicist, so I'm very excited to chat with you. I'm awesome. Very excited. I'm very, very excited. But, before we get into the science, I know that you are also an avid reader. So just out of curiosity, what is a current book that you're currently reading or one that you've read recently? What can you tell us a bit more about it?
Yes, I do love reading. Currently, I'm reading a book called Addiction and Grace by Gerard G. Mayer, who is was an American psychologist and theologian. It's a really good book, very short, but has some really profound lessons, and I would highly recommend it to anyone.
That's great. So you tend to read books when you choose the books you read. Do you specifically try to delve away from your subject of choice? Is it like a way for you to distress?
Yeah, we can say that. Here's the thing. I'll just say that I love reading, but growing up, I never really liked reading. I mean, I would study. I was very good at studying. This is just studying math, science, anything that has to do with academics. I would study. But in terms of reading, I just thought it was taking away time from my studies. But I remember in high school, or mid school rather, I started reading the book, what was it called? Things Fall Apart. Yeah, because it was assigned for a class. Yeah. And so after I went through that, I was like, oh, wow, I guess you can learn other things besides just school stuff. And so that got me into reading. And then for some reason, I don't know, maybe this is just like the science part of me, but I tend to stay away from fiction stuff. I mean, I would read like fictional stuff on like maybe like astronomy, just because those are like fun stuff. But most of my journals are sort of like philosophical type of books. So just because I love philosophy as well. So yeah.
Okay, that's quite interesting. I just want to touch on what you said, that when you were younger, you were heavy into, the studying aspect. So then this will just bring us back into the question. What were some of your influences that got you into this field of STEM? It seems like it was always something that you really enjoyed from a young age. Was it because of other people, or did you always know that this is something that you want to do?
Well, I would say naturally that I'm a curious person, always trying to figure out how things work, always trying to figure out how to fix things. But growing up, I wanted to become a doctor just because, as most kids back home, we're always taught, if they see some potential in you, we're always taught you have to be a doctor. The closest thing that you can be is an engineer. And so I always thought, I figured I was going to become a doctor. All my high school teachers thought, that's a doctor, he's going to be a doctor. And so up to all the way through high school, I thought I was going to become a doctor. But when I was in high school, I remember a time when my English teacher, he said something like, the reason why Africa is poor is because most smart people only aspire to become doctors and engineers. And he asked the question, why don't you guys aspire to be anything else rather than that, like be a scientist?
Wow.
Yeah. And so at that time, I didn't think much of what he said. And at the same time, I didn't like the teacher. I mean, he was too critical on me. Like, if I miss, because he was an English teacher, if I miss any little thing, like he would take off so many points, and other people, he would just like let them slide. And so in response to his question, I just told him, hey, I mean, I don't think we have the facilities to study, to become a scientist or stuff like that. And then he said, well, why don't you go where there are facilities? And even though at that particular moment, I didn't think of this to be like, something that stuck with me. But looking back, that's something that like came to me when I was applying to schools. Like I wanted to become something rather than a doctor. Like the more I got closer to going into college, like my love for being a doctor was slowly dying off. But I think the fact that people are expecting me to become a doctor, always, I think I fell in love with the idea that I was going to become a doctor. But I ended up changing it a little bit when I started watching a lot of like fast cars, and I fell in love with fast cars, and I want to build fast cars. And so when I was applying for college in Zambia, I remember all my friends were like, we're applying to School of Medicine and stuff like that. And I put down two things. I said, my first choice, it's going to be medicine. My second choice is going to be electrical, mechanical engineering. But also at the same time, I was watching documentaries on quantum physics, and that just like blew my mind. I'm like, whoa, all these concepts about particles and how they behave. And that's where the curiosity grew. And I knew that I wanted to study physics at that point. That's a long answer, but that's how the spark for science became a thing for me.
That's quite interesting. That's quite interesting. And I think, when you mention your English teacher, I think it was really good that he pushed you and he asked you those hard questions, because I think sometimes I think growing up, most people in our age group, all we were exposed to were engineers and doctors. So it's really good that you had somebody questioning you, like being, no, why can't you be better? And why can't you be something else? So I think as much as you might have hated him at that moment, but I think he probably saw something in you, and then look at you now. But also I think kudos to yourself, because you went out and explored other things. So kudos to your curiosity as well. Like you said, that because of all these documentaries that you watched, that's how your mind. And I think that just shows that the more you're exposed to things, the more your mind will be like, oh, okay, there's other things than being a doctor and an engineer. Which is, I think
that's one thing that most of us, especially back home, my country, I mean, we're not like that exposed in what career path we can take. We're only limited to what's the best career. Okay, medicine, engineering, maybe human resource, like those, but beyond that, we don't think outside the box.
Yeah, that's true. So then take us, here you are, you've been challenged, you've applied at all these, you've got your 3 choices. How do you end up in America?
So right after undergrad, I was introduced to this program called United States Achievers Program, where they would pick some of the promising students that would like to study in the USA, and they would prepare them for the exams that you have to take, the SATs and stuff like that. So I was part of that program right before my first year of college in Zambia. So I did that. I applied to schools, and at the same time, but when I was applying to the USA, the whole idea of being a doctor, that's where it actually died off, because I looked into the possibilities of becoming a doctor, and I'm thinking all these years, and I don't know if I'll be able to to get it, because in the USA you have to do 4 years and then 7 more years. I'm like, I'm gonna go a different path. Yeah. So then I knew that definitely I'm not gonna do medicine, and then I just applied through the same program, and I was accepted at a university in the USA. So that's how I ended up coming here.
Oh, okay, that's quite interesting. So you went and you found places, like you said. I remember you said your one excuse was that you don't have the facilities. So you went to the place that had the facilities. I really like your English teacher. Like, the more you speak, the more he had a point. He had a point.
I remember one time I went back to him. I went to visit the Ask, and he was there, and he was asking me what I'm up to and what I'm studying. So he asked me, are you studying medicine? I was like, no, I'm studying physics. And he's like, oh, wow, really? It's like, what do you want to do with physics? I was like, I'll become a scientist. It's like, oh, wow, that's impressive. And he started telling me juniors, that were my juniors, at least in high school, say, oh, this one is also doing this type of science. I'm like, oh, wow, they're not in medicine. I was like, yeah. I was like, okay, that's good. But yeah.
That's great. It's great that you went back. I think that must be such a fulfilling moment, especially for an educator. That must be such a fulfilling moment. Okay, so you took the SATs, and you arrived in America, which is really, really good. So that's when you started studying physics from undergrad, right?
Yes.
Oh, okay.
So in undergrad, I was interested in physics. I wanted to pursue that. But when I started taking the classes, I realized that the problems were very complicated. And so, and everything was done by hand. And for some reason, I just had this inclination that I probably should also study computer science, so that maybe there could be ways that I could use computer science to solve my physics problems. So I also majored in computer science.
Okay.
Yeah.
Oh, that's very interesting. So fast forward, now you are doing your PhD and in nuclear physics, right?
Yes.
Before we get into what you're studying, I just quickly want you to explain briefly what, if you can, what nuclear physics is before we get into what your topic is, and then you can tell us more about that, like in a brief manner, like a little brief overview, because I think most of us know, like we know the word, but I don't think we fully understand what it is.
Yeah, most of us know the word in relation to weapons, but nuclear physics, let's see, in a nutshell, basically what we're trying to do is to understand the physical structure of a nucleus. So a nucleus is the center part of an atom, so it contains protons and neutrons. And our goal is to try and understand the physical structure and also the processes that are taking place within the nucleus, like what holds the nucleus together, what makes it split, what other particles are in the nucleus. And so basically when you think of nuclear physics, you're basically just studying the nucleus of an atom. That's in a nutshell.
Yeah, that makes sense. That makes sense. I hope we now understand. So what you're studying, like I said, you are doing your PhD in nuclear physics, studying low energy experimental nuclear physics, specifically studying the nuclear structure of neutron-rich nuclei. Can you tell us more about this research and why it is important that you're doing what you're doing?
All right. So I guess the fact that there's a word law, and I should talk about what that means first. So low energy nuclear physics is the type of nuclear physics where you just look at the basic processes like fission and fusion. And then when you talk of high energy nuclear physics, then you're talking about nuclear particle physics, which is now it's known as particle physics, but it's basically high energy where they use accelerators to run nucleus together and make them hit each other and break into pieces, and they start trying to figure out what are the components that make up the nucleus. But for low energy, we just focus on things that we already know, the protons and the neutrons. Yeah. So my focus, as you mentioned, is low energy experimental nuclear physics, and specifically I'm studying the structure of neutron-rich nuclei. What that means is that we're trying also to, in a grand scheme of things, we're trying to study the physical properties of a nucleus. And these nucleus have a high number of neutrons compared to protons, and that's the reason why we say neutron-rich, because they have more neutrons, and because of more neutrons compared to the number of protons, then that renders that nucleus radioactive, meaning it's prone to radioactive decays. So for my projects, most of them I study the spontaneous fission products of Californium-252. So California in this case is a neutron-rich nucleus, and in my field we say heavy nucleus because it's like 252. That's like too much. So we say it's a heavy nucleus, or if you're around my professor, he would say heavy elephants or heavy elements, but you call them heavy elephants. So, yeah. And there are varied ways of how people go about studying the structure of the heavy nucleus, but I'll talk about one of my recent projects and hopefully to help like shed some light.
Sure.
As I mentioned, I study spontaneous fission products. Therefore, if we were to try and understand that, maybe we should start by defining what fission is. So basically, fission is just a process by which a heavy nucleus, in my case is Californium-252, splits into two or more other fission products. So in this case, it could be like a pair of barium and molybdenum pair. And there are few ways by which this happens. Sometimes when you talk of fission, you can talk about neutron induced, where you shoot a neutron in a nucleus and it splits. But in my case, I'm studying spontaneous, meaning the nucleus splits almost naturally, so to say.
Okay.
Yeah. And so the reason why they split spontaneous is because they have like this high energy, so they're really excited, and because they have a lot of neutrons, they're usually in a deformed shape, so they want to like get rid of that energy, and so they split into two. And depending on the energy that they have, the nucleus will split into two, but in the process of splitting, it will release neutrons. So when it's splitting, neutrons will be released, or sometimes they're not released. And generally in my field, there are two types of modes that people agree upon. There is the first mode where neutrons are not emitted, and we call this the cold fission mode, where a nucleus splits into two new products, but no neutrons are emitted. And there's also what we call a hot fission mode, where 1 to 8 neutrons are emitted. And so for my study, I tried to study how many neutrons can be emitted given any fission process. And in my recent paper, I was able to show that even though in the past years we've told ourselves that 1 to 8 neutrons can be emitted and that's it, one theorist in our group suggested that there could be more, and I was able to show that actually we could have up to 11 neutrons that can be emitted in a fission process. So that changes the way we understand fission, or the type of modes. Instead of having 2, now we have 3. So that's basically a short version of my research.
Wow.
Yeah.
That's very interesting.
Yeah. To answer its importance, since the work is very basic, like it's very fundamental, so we try, the main goal is to try to get as much information as we can on fission processes, and this is used to help in building nuclear reactors, nuclear weapons, for medicine purposes, and also for discovering new elements on a periodic table.
Okay, that's interesting. So you mentioned what you do. So I just want you to explain typically what is a typical day in the lab? Well, this is obviously before COVID-19 happened, because things have changed now. But what would a typical day be like, and what is the best part of doing what you're doing?
A typical day for me usually involves me sitting behind a computer and analyzing fission data. And this is coupled with solving some statistical problems and taking notes. And the reason why that is the case is because even though I'm an experimentalist, I only get to run like one experiment once in a while, and from that experiment we get a lot of data sets, which can be it can be hard to sort through or search for new insights. So and the way I do this, maybe let me give an illustration. Like, you have all this huge data set and you're trying to get spectrums to see what energy transitions belong to what nucleus. And you can think of it as like giving a kid a Christmas gift wrapped in a box, and they're shaking it, trying to figure out what's inside the box. Like, that's what I do with my dad. I just shake it up and see what new insights I could get from it. That's basically how I spend my day. The best part is I'm guaranteed of getting results every time I sit behind the desk, which is not very common for experimentalists, because you can go for months and even a year without getting results. But whatever time I spend behind my desk, I get results, whether it's good results or not so exciting results. I'll still get something at the end of the day. So I like that part. And also I like automating my problems, where if I can see that I have to repeat this experiment several times, I'll just write a script and it will do that for me. Then I can do something else, watch TV or read something. It just depends on how I'm feeling. So yeah.
Okay. That's pretty interesting. That's pretty interesting. And also, as we get into this sounds like it's a really interesting project that you're part of. I just wanted to ask you, when you kind of sit back and you think of Brooks when he was in Zambia, what do you think now, some opportunities that being in this field of STEM like has afforded you? What opportunities rather has being in the STEM field afforded you?
Lots of opportunities. I mean, looking back, I think it's always easier for me to think of what I would be or what my life would be like by looking at the friends that I started my journey with, the college at least, and I'm looking at what they're doing, and people back home at least, and I can sort of see the differences. And for me, I think the opportunities that have given me is I have being in a STEM in the USA, I have the facilities to do what I need to do or how to get by finding results, and I'm afforded that opportunity. And also there's a lot of travel involved, conferences. And for some reason, I don't know what's up with nuclear physicists, but they always pick like the best places to go to conferences. So that's always a good part. Yeah. And then we can talk of collaborations, great people, where currently I'm working with a group from India. I've worked with a group from Russia, China, German, and Canada, and all these places within the USA that I can collaborate with, which is something that is unique being in the STEM field. And again, you get to work with really big people, important people that the world looks up to. For example, this is like a really cool fact, but I love it. My advisor, my peer advisor, actually is one of the people that was involved in the recent discoveries of the elements that were recently named on the periodic table. Yeah, specifically element 117, which is named after Tennessee, the state of Tennessee, Tennessean. He was one of the 4 people that contributed to that discovery. So you have people like that on your papers, which is like something that is just astounding, because you get to work with such people, like people that know their field really well. And I like that.
Definitely. Like you said, traveling and the collaborations and having these celebrities in STEM is pretty exciting. It's really, really exciting. That's amazing. So you just mentioned that when you were thinking about how things would have been if you had stayed in Zambia. I know you're also pretty passionate about the future of Zambia. So I wanted to ask, do you plan on going back after your studies? Because I know some of us who study abroad, we, as young Africans, we tend to set firm roots where we are and not many return home. So I wanted to ask, are you planning on going back?
Yes, I am passionate about Zambia and just the development of Africa in general as a continent. So, yeah, I do plan to return, even though it might not be immediately after I graduate, because I need to get some work experience and stuff like that. But I do plan going back eventually, back home, yeah.
And yes, while we are on this topic, do you think that the non-return of Africans is the reason why Africa might be lagging in terms of progression? Because I'm playing devil's advocate here because because our educated people do not return to implement all of this knowledge. So like to return all of this knowledge, so to better Africa in terms of the future. Do you think that is a problem? Yeah, I'm really playing devil's advocate, but you can amuse me with your answer.
Well, I mean, you are talking to someone from abroad, so I might be a little bit biased, but that's a good question. It's a tough one too. And I would say before I give my answer that I'm not an expert on the development of Africa or stuff like that. But so to those that are listening in, please do not quote me on this, but I'll just give my opinion. So it's not an expert's opinion. Don't quote me on it. But to answer your question, I will say that, yes, it is true that Africa might be in a better place if all the educated people came back and implemented what they have learned in their respective countries. And I'm definitely an advocate of people who study abroad returning to their own countries. But for me, the question doesn't end there. I think in as much as we like to think to say, okay, those that are studying abroad can make the difference, I believe rather, for any change to take place, we have to start from where we are, maybe in a scope of the country. We have to start from where the country is at that particular moment. And what I mean by that is, for example, let's think of, I'll just ask this question. Are all the smart people from Africa, have they all left Africa?
Yeah, good question.
Yeah, the obvious question is no, because I have friends, really smart friends that are still in Africa. And so I always ask myself is, do we have to wait for those that went away, or because they can bring something back, or what is the government or what are the African governments doing to specific individuals that are already in the country, like the graduates? Are there support systems to help them implement their own ideas that they have, so that even those that would come back, what are they coming back to find? Like, would they find a support system that will help them implement the ideas? Because right now, we have these programs that have been going on, at least in Zambia. I don't know for other countries in Africa, but in Zambia, we have the government that sends people to Russia and sends people to China on a scholarship basis. And these people come back. These people do return to Zambia. But when they return, they're forgotten about. It's like the government did not spend money to send these people abroad, and then when they come back, there's no opportunities for them. There's no places to say, okay, we sent these people out to learn this. Let's create an environment for them to come and practice what they learned. No, they're just forgotten about it. Like they never sent anyone out. So then what's the difference with those that are coming back then and those that would come back from maybe the USA or England? Like, what are they going to find? And I think that's like the most challenging thing that I engage in this conversation, and I talk to my friends here, say, well, why would you stay? And the thing is, they always feel like when we return, we're not going to be treasured, we're not going to be valued for our worth, or for example, scientists, especially people in higher fields that are not prominent in Africa. So, for example, if I were to do nuclear physics in Zambia, I'm not sure how I would apply that. I would apply it in energy sector, but that would limit my potential to grow. And so those are the dynamics that people look at. But regardless of the situation, I still think that we should retain and develop our respective countries in Africa.
No, you make valid points. You make valid points that it needs to start in the African countries for the opportunities who are currently there, and also for those that return. I think that's a very important point. And so that things can move forward. Like what exactly is there is a very good point that you've made. And in closing, I just want to ask you, what advice would you give to somebody who's interested in getting into the STEM field, and specifically in your field of nuclear physics?
Well, let's say in a broader stroke of like STEM field, if you're interested in STEM field, you better be committed and love that's what you're going to do, because even though it's like really cool, you got to solve problems, I think we shouldn't limit ourselves to the fact that we'll be stuck in those fields. I like to think of STEM fields as a vehicle that prepares people to think critically. And if we are to solve African problems, I think we need people that are well trained to think critically and identify problems and figure out solutions. And I believe most people in the STEM fields are well equipped with that. So if you're interested in a STEM field, don't limit yourself to that field. Like, think of how you could apply the knowledge that you've learned and transfer them to solving social problems, cultural problems, traditional problems within Africa. For someone interested in my field, I think it's a really fascinating field. There's a lot to learn. You can never really be bored because the problems are really challenging, and so you're always kept on your feet, and the problems are endless. You're never out of something to do, which is something unique and I think exciting. And you get to do really intense experiments that could put your name out there, which is, I think, something that we as scientists aspire to do. Yeah.
Oh, that's some really good advice. Thank you so much for this advice, and also just taking us through your journey and teaching us about what you're doing. It was really great chatting with you.
Same here. Thanks again for having me. I'm pretty sure maybe once I update my career path or stuff like that, we could chat again.
Definitely. Yeah. Hopefully it'll be on, like you said, when you've updated your career path on a bigger level, and this podcast will also be on a bigger level when we've both leveled up.
Yes.
When we both leveled up, definitely.
Yeah.
Definitely. Thank you so much. And to everybody else who is listening, thank you once again for tuning in to another episode of the Roots of the Science podcast with your girl, and with an E. Until next time, goodbye.